Alright, so we're going to start off with this idea right here, this example. It's talking about a meal plan of some sort. This meal deal at Banana Bees allows you to pick one appetizer, one entree, and one dessert for $10.99. A couple questions I want to ask you guys. If you were presented with this situation, right, you can pick one entree, one appetizer, one dessert. Does your choice of appetizer limit your options for the entree or dessert? Does it limit, like if you pick this appetizer, does that mean you can't choose this entree? No, you get to pick whatever you want from each option, right? So your choice of one does not impact the choice of the others, right? That's what I was saying before. So underline this word, independent. When your choice for one object does not impact your choices for other objects, that is called an independent event. Right? If you have a group of those things all together where the choices don't impact each other, those are called independent events. Alright, so we have this cool rule called the fundamental counting principle that helps you find out how many combinations you can have of these options. So it says if one decision can be made in n many ways, you replace n with a number. Okay? And then some other decision you're trying to make can be made in m many ways, that's another number. If you're trying to figure out how many ways you can have the two decisions put together, you just multiply the two numbers together. So if you could pick 2 different ways for this one and 3 different ways for that one, just take 2 times 3, that gets you how many times you could pick both of them together. That's the fundamental counting principle. So for example, a student is going to flip a coin and roll a die. So flipping a coin and rolling a die, how many possible outcomes will there be? So these events are independent. Why are they independent? If you flip a coin, is that going to affect what number you roll on the die? No, they're completely separate. So those are independent events. How many different outcomes do you have for flipping a coin? 2, heads or tails, right? How many outcomes are there for rolling a die? 6, 1 through 6. Therefore, if you're going to put both of them together, how many different options do you have? 12. So you can have heads and then roll a 1, heads roll a 2, heads roll a 2. All those. If you kind of listed them out one by one and add them together, you get 12. But the quick and easy way to do it is just multiply the two numbers. Okay? Here's another example. For a college interview, Robert has to choose what to wear from the following options. He has 4 slacks, 3 shirts, 2 pairs of shoes, and 5 ties. How many possible outfits does he have to choose from?
What color are the shirts?
Regardless of fashion sense. How many different combinations could he have with his articles of clothing? How did you get that? 4 times 3 times 2 times 5. That's 120. Of all the options, of all the different ways you could choose stuff, if you multiply them all together, he could have a potential of 120 different unique outfits to choose from. Not all of them are going to be great, but he has that many options. Okay? So going back to the question I introduced at the start. The meal deal at Banana Bees allows you to pick one appetizer, one entree, and one dessert for $10.99. How many different meal deals could you create if you have 3 appetizers to choose from, 6 entrees to choose from, and 4 desserts to choose from? How would you find out? Okay, that's going to be right? So if they give you a bunch of independent events and ask you how many different possible outcomes you could have with all of them put together, just multiply your options. Okay? Alright, so we're going to talk about 2 specific types of situations where you guys might be working with situations like that, like above, where they're a little bit different though. So we have permutation and combinations. For a permutation, order matters. I can't remember if we got to that word when we were doing the definitions on the vocabulary thing. But permutation, I'm going to define this and then talk about this list here. Permutation is arrangements of items where order matters. Arrangements of items where order matters. So for instance, how people finish in a race. Right? Order matters because that's how you decide who is first, who is second, who is third. Right? Arranging letters to create actual words. right? To spell the word cat, C has to be first, A has to be second, and T has to be third for you to actually create that word, right? Getting people seated, right? If Anthony is in this desk is now off limits, right? So now the next desk would be this one. There's a specific order in how people are seated because when somebody sits down, that chair is off limits. Creating a password, right? If your password, if you jumble up the letters, it's not going to work, right? It has to stay in that particular order each time. Assigning positions of power. So if you guys are in a committee, you have the main person, the secretary, or whatever. Assigning positions of power is another one where order matters. Situations where order does not matter. This is a combination which we're going to talk about in a second. Situations don't matter when you guys are choosing people. If you're trying to create a group, like let's say I was trying to create a group of 3 with Gavin, Ellie, and Melissa. Does it matter whose name I say first? No, you guys are still a group of 3. It doesn't matter who I name off as your group. So when you guys are trying to choose people and create a group or a committee or something, order doesn't matter. Choosing 2 desserts from a selection of 5. If you know you're going to pick 2, does it matter which one you pick first? No, you're still going to pick 2, so it doesn't really matter. Answering questions on a quiz. Does it matter which one you answer first, as long as you have answered all of them? So those are situations where order doesn't matter in the context. So the tricky part about this lesson is reading a question like a word problem and knowing whether order matters or whether it doesn't. Because you have to use either a permutation or a combination, you have to know which one to use. That's the tricky part about this lesson. Right, so you have to think about it a little bit before you can figure out which one to use. Right? But actually using combination permutation is not difficult because you're going to be using your calculators to do it. Plus there's the formulas on the formula sheet, so you don't have to memorize them. Alright, so permutation order matters. Keywords you guys will see in word problems. These are not, this is not a full list, this is not a comprehensive list of the words they might use. But if you guys see the word assign, arrange, or elect, those are usually signal words in the word problem that you're going to be using permutation. So assign, arrange, and elect are oftentimes the words they use to signal its permutation. We're going to be using the fundamental counting principle. That's what FCP stands for. After each event, there's one less option for each consecutive event. So I'm going to go back to the seating at desks idea. So there are 28 desks in this room. If Anthony sits down, how many desks are there left to choose from? 27. Then if Kenneth sits down, how many are there? 26. So see how for each event, the number of possibilities goes down? That's how a permutation works. The number of possibilities for the next event to happen goes down. So what we're going to be doing is using a factorial. It's a new idea that we're learning about. A factorial. A factorial, which looks like this, 5 exclamation point or some number exclamation point. That means you're taking that number and multiplying it times everything that's underneath it. So 5 factorial will be 5 times 4 times 3 times 2 times 1. This would be like 8 factorial, which would be 8 times 7 times 6 times 5 times blah, 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 blah. That's what a factorial is, okay? So when they ask you something like this, how many possible ways are there to complete 8 dependent, look, I changed the word, dependent tasks. The ones we were talking about at the top of the page were independent. One decision did not affect another. When it's permutation, they are dependent. So one decision will impact future ones. Just like when Anthony sat down, that affected how many seats we had left to sit in. Okay? So we're going to be using 8 factorial. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I don't remember what it is. 40,000. Right? So the reason why we're doing it this way is because if there was one task, and the first task we had 8 options, but once you completed that, you only had 7 options, and once you completed that, you had 6 options. That's how permutation works. The options decrease as you're going through the process. Okay? There's a shortcut in your calculator. So, let me see if I can remember how to do it, because I haven't done it in a while. Everybody go to the math button. Math button. And then you want to scroll over in the top to PRB, probabilities. Option 4 should have a little exclamation point. You see that? Okay. So go back to your main menu, right? Clear everything. Let's try doing the 8 factorial. So we want to hit 8 first. 8. Then go to math, PRB, option 4. So And on your screen it should say 8 exclamation mark, push enter, and then it gives you the factorial. Alright, that's how you guys get to do factorials in your calculator. You don't have to do each number separately. Because once you get 20 factorial, that would be awful, right? 20 times 19 times 18. Ugh. So you guys have a special number or keystroke in your calculator.
It's more cooler than the sun does not have no
Anyways, alright, let's look at this question. This one's a little bit different. So this one says that there are 12 acts auditioning for an 8-act talent show. So there are more people auditioning than there is room in the show. We want to know how many different ways can the acts be chosen to fill the 8 slots. So let's think we're trying to pick the first act. How many options do we have to choose from? Well, there are 12 people auditioning. We have 12 people auditioning. We're going to pick one of those 12 to be the first act. Then, for whatever, reviewing the auditions or whatever, how many options do I have for the second act? I have 11. I've chosen one act already from the 12, so that means I have 11 left to choose from. What about the next act? 10, 9, 8, 7, 6, 5. We're cut off. Right. We only have 8 that we're choosing from the 8. Or sorry, from the 12. We're only choosing 8 from the 12, so we're cut off after we have the 8 filled in. Right? So this is where the formula for permutation comes in. Okay? Is it printed at the bottom of your page? It is not. So I'm going to have you guys write it down. So underneath this question, I want you guys to write little n, big P, little r. I'll explain this in a second. Little n, big P, little r equals n factorial divided by parentheses n minus r parentheses factorial. Just write it. Okay. This right here, out loud, this means you have n options, and you're choosing r of them for a permutation. So if you guys want to write a little bit of notation, this is your options. N, little number here, that's how many options you have. R is how many you want. How many you want. Turn it off here if you need more space, but this is how it works. So the notation, when you guys see like a question on the homework, they're going to have a number here, capital P, then another number. That's telling you how many options you had, and then how many of those options you wanted. So for this example, I would have 12P8. Right? Now all I need to do is plug in n and r into this formula. So what's n? How many options do I have? 12. So I have 12 factorial in the numerator. And then in the bottom, I'm going to do n minus r, which would be 12 minus 8, which is 4 factorial. So when you guys are cut off, when you're not doing a full factorial, you're cut off a little bit early, you have to use the permutation formula like this. Okay? So in your calculator, same thing, just go to 12, and then use your keystroke to get to the exclamation point, and then divide that by 4. Exclamation point. You're going to get big numbers. 1999. You will get big numbers. Okay, this formula you do not need to memorize. It is on the formula sheet. You just need to know what n and r stand for and how to plug them in. Okay? So the reason why, hold on, before we move on, the reason why I had to use this formula is because this was not a full 12 factorial. If it was a full 12 factorial, how would I write it? Just times 5 times everything until 1. This was cut off. So the reason why you guys use this notation is when your r is smaller than your n. When you're only choosing some of the options that you have. That's why I have to use this formula. Okay? There's the formula. There it is. So again, it's called permutations of n items, or options. taken R at a time. R is how many you were wanting to use. Okay? So I have several more examples here we're going to talk through. So a combination lock will open when the right choice of 3 numbers, 1 through 30 inclusively, is selected. So that means that your options for numbers are 1, 2, 3, blah, 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 29, 30. You have all those options, okay? How many different lock combinations are possible if you do not repeat any numbers? So anytime you use a number, you can't repeat it. How do you think you would do this? You want to think about how many options do you have, and how many of those do you want to use? Hold on, I want you guys to write the notation. So I have 30 options, 1 through 30, that's 30 numbers. How many of those numbers do I want?
3.
I want 3 of them because my combination lock is just going to use 3 numbers, okay? So if I plug it into the formula, what would it look like?
30.
30 factorial divided by 27 factorial because you do n minus r to get the bottom. And then you just put that in your calculator. Yep. Alright, now this part that I bolded, I want you guys to underline it because that is super important. When you guys see the wording that says no numbers repeated, so that's going back to the idea of when Anthony sat down, this desk was off limits, right? Same thing as when you guys are choosing things, if you're picking a number and you're not allowed to repeat it, that means it's off limits. That's why we were able to use this formula. That's the definition of permutation. When something becomes off limits, once you've filled that spot, that is when you use a permutation. What's different about how this is worded? All the words are exactly the same except for what little part? Numbers can be repeated. So that means if I use 1, can I use 1 again?
Yes.
Yes, it's not off limits. So this is actually not considered a permutation. We have to think about this a little bit different.
Combination.
It's not a combination either. This is kind of a weird idea. When you guys, we'll think we have 3 numbers to fill, right? We have 1, 2, 3 numbers for our code. How many options do I have to pick for the first number?
2.
It's still 1 to 30, so I have 30 choices. I have 30 choices. 1, 2, 3. I could pick any of those numbers for my first one. Now, if I'm allowed to repeat, how many do I have for this one? 30. If I'm allowed to repeat again, 30. So 30 times 30 times 30.
Equal.
Remember the kinds of situations we started with at the very, very start. What were those called? If you make one decision and it doesn't impact the next one. Independent. So this is independent. And this is dependent. Okay? When your situation here is independent, you just use the fundamental counting principle. That's what we started the lesson with. I had 30 choices, 30 choices, 30 choices, multiply them together. So when they're independent events, that is not technically a permutation, although it's kind of worded the same way. You're just using the fundamental counting principle like we did on the first page. Right? But if they are dependent, that means that your options go down. As you choose one thing, then you have a restriction on the next options. It goes down. That's when you use a permutation. So I put these next to each other so you guys can see the difference. Okay? Alright, what about this one? From a club of 24 members, a president, vice president, secretary, treasurer, and historian are to be elected. Keyword, that tells me it's a permutation. These are positions of power. Once one gets filled, you can't use that same person for another position, so it's a decreasing number of options. And how many ways can the offices be filled? So how many people do I have to choose from? 24. So those are my options. So 24, key. How many of those people do I want to elect for these positions? President, vice president, secretary, treasurer, historian. 5. I have 5 positions to fill. So of the 24, I'm only going to be electing 5 for positions. Okay? So how should I write the formula? 24 factorial over
19
factorial. Make sure you don't forget your exclamation marks.
Oh,
5,100,480. A lot of different ways to elect these people. Yes.
What's the point of finding the time?
Oh. The point of?
Yeah.
They're asking how many ways can the officers be built. That's why we're using permutation.
you do have different combinations there are for March Madness.
No.
For extra credit?
No.
Why not? That's a good
Alright,
idea.
our last one here. Hold on. There are 3 students left in the spelling bee. I don't know how many started, but there are 3 left. Arnold, Beth, and Corey. Prizes are awarded for first and second place only. So, for third place person. How many different ways can these prizes, first and second, be awarded? So, how many different awards do I have? Or sorry, how many people do I have to potentially? Okay, so I have 3 people, but I'm only going to choose 2 of them to earn a prize. So of the 3 people, only 2 of them are going to get a prize. So how would I write this as a permutation? 3 factorial. Oops. Yeah, it's not 3i.
Exclamation point.
It's an upside down I, but it's not 2. What would be in the bottom? 1 factorial.
One is upside down line.
Should be 6. 1 factorial is just 1, by the way. Also, strangely, and I have no idea how to explain it, but 0 factorial is also 1.
What the? Impossible. You went to college.
I have I cannot explain it. I have no idea why. But 0 factorial is 1.
If that's possible, then that means there is a negative 0.
Yes, 0 is both positive and negative.
Ha!
Alright, so that's permutation. Permutation is once you choose one thing, your options decrease. Alright, that's when you use a permutation. Combination is when that is not true. Alright, so combination is collections of items. Collections of items where order doesn't matter. Collections of items where order does not matter. Alright, so that's like in the list that we had on the previous page when you guys are selecting people or when you're grouping people. Doesn't matter who you name first, they're going to be in a group anyway. When you guys are picking out things from a group where it doesn't matter which one you choose first because you're getting 2 or however many anyway. So keywords you guys might see would be choose or group. In a word problem, choose is a little bit iffy. Sometimes choose means combination, sometimes it means permutation, so I'd be careful with that one. The group usually means combination. Now because order does not matter, there are going to be fewer outcomes than if you guys had permutation, right? Because the order doesn't matter. So for example, for a permutation, 1, 2, 3, and 3, 2, 1 are different, right? The order is different. 1, 2, 3 is different from 3, 2, 1 if you consider the order, right? But for combination, because order doesn't matter, 1, 2, 3, and 3, 2, 1 would be considered the same. Because it doesn't matter what order they're in. You just have 1, 2, and 3 in a group, okay? So when you guys are working with combination, your numbers are going to be a little bit smaller. You guys are working with these, and we have a different formula. Again, this one you do not have to memorize. It's going to be on your formula sheet. So for the combination, it's still the same thing. You have 7 options, and you're trying to choose just R of them. But this time, you have the permutation formula with an extra R factorial on the bottom. The extra R factorial on the bottom is canceling out the repeated orders. So remember how I said 1, 2, 3, and 3, 2, 1 are the same? The extra R in the factorial canceled out the repeated representations of those orders because you only need one of them and it represents all of them. So the extra guy right here, that's going to shrink the number down to represent that order does not matter. Okay? So we have a couple of examples here to illustrate what the word problems will look like for combination. So this one says a student must answer 3 out of 5 essay questions on a test. How many different ways can the student select the questions? So the student knows he has to pick 3. They're all separate questions though. Like there's this prompt, this prompt, this prompt, whatever. They're all separate. They're not reliant on each other. These are independent events, right? So once he picks one essay, is that going to affect his answer to any of the others? They're all separate, so no. This is a combination question. So how many options does he have to choose from?
5.
5, and we know this is a combination because the order does not matter. And he's choosing 3. Okay, so in the formula, it would be 5 factorial divided by r, which is 3 factorial, and then 2 factorial. Because n minus r is 2. So you have an extra factorial on the bottom.
And the R and the other R will be subtracted.
Does everybody see how I got the numbers? R is 3, so that's the r factorial. And then n minus r, 5 minus 3 is 2, so you have an extra 2 factorial. So in your calculator, you just put it in.
You put parentheses or
You should actually include parentheses, like this. Some calculators mess it up, some don't, so just so you guys just have a general idea. Put parentheses around the denominator. It should be 40 now. So that means your calculator is not safe, so use parentheses. So it should be 5 factorial divided by parentheses 3 factorial, 2 factorial. You get 10. Should get 10. You have to have parentheses around the entire denominator part.
elementary smaller. Smaller.
Alright, everybody get to 10?
Let's save that minus.
It should be 10. You need the parentheses in the bottom. 0.5?
Yeah.
Oh, you're messing up then, bud.
105.
You got negative 0.
Alright. Yeah. If you put the parentheses. If you don't use parentheses, you're telling your calculator I want you to do 5 factorial divided by 3 factorial and then multiply that times 2 factorial. So if you don't include the parentheses, they think the 2 factorial is out of the bracket. Alright, so this next one. To play a particular card game, each player is dealt 5 cards from a standard deck of 52 cards. How many different hands are possible? So, think about dealing out cards. If you're given 5, you're going to get those 5 cards. Does it matter which one you get first? You're going to get all 5 anyway, so it doesn't matter which one you get first. That's why this is a combination question, because order does not matter. Okay? So, how many options do I have to choose from? 52. And of those 50, of the deck of 52 cards, how many do I want? Just 5? Okay? I need you guys to make sure you're writing down the notation here. That is a skill you guys need to know how to do. Write down the n and the r. Alright, so then the top is just your n factorial, then you have r factorial, and then you subtract the 2, 47 factorial. Make sure you put parentheses around the bottom before you put it in the calculator. Okay, this one's a little bit of a big number, just because n is so big. 52 is a rather large number. Yep. Just imagine what that number would be if you had done permutation. You can still get big numbers. The bigger n is, the larger the answer is going to be. Okay? Our last one here. Becky was allowed to choose 5 of 8 short answer questions and 2 of the 4 essay questions on an English exam. How many ways could she choose all of the questions for exam? So this one's a little bit of a twist. We're going to have 2 different things going on here. I have the short answer and the essay, so I have 2 different things that I'm working with. Are they both, well, hold on. Are they both independent? Does her choice of short answer impact her choice of essay? No, so they're independent. Alright, so what we're going to need to do is look at this one, separate from this one, then we're going to have to figure out what to do once we get those 2 results. Alright, so if I'm, hold on, the answer is no to that, it's not adding. So if I have 8 short answer questions and I'm choosing 5, does it matter which one I choose first? No, I'm just going to pick 5 and answer them. So I have 8. Combination, because order doesn't matter. choose 5. So 8 options, choose 5 of them. So I'm going to have 8 factorial over 5 factorial, and then an extra 3 factorial. That's n minus r. Plugging into the formula. Go ahead and find that value. 56. Alright, so she has 56 ways of choosing her short answer questions. Now let's go ahead and do the essay. Hold on. Don't rush ahead. How many options does she have for the essay? 4, and how many is she choosing? Does it matter what order? No, this is a combination. So you have 4 factorial. Yes. Parentheses. Oops, that's a parentheses. 2 factorial times 2 factorial is not 4 factorial.
No, but it's 2 factorial squared.
Yes, but I don't know if the calculator will recognize that.
We can try.
Alright, so think about this really, really carefully. She has 2 independent events. She has 56 options for this one and 6 for this one. What do you do when you have independent options that independent events? You multiply. That's what we did at the very start of the lesson. Independent events, the fundamental counting principle. 56 times 6.
3,
36. You guys have to keep that in the back of your mind. If you have independent events, 2 different separate things happening, you have to multiply them together to get all of the options for both of them. There you go. Alright, I have a cool calculator trick for you guys. Okay? So you know how we were able to find the factorial using our calculator? We can also find combinations and permutations using our calculator. However, that does not change the requirement that you guys have to write the notation and plug the numbers in for the formula.
Are you kidding me?
I need you guys to write at least this much for each question. You need to write down the notation, how many options you have and how many you're choosing from, and show me what it would look like if you plugged it into the formula. But then you can use your calculator really quickly to just find it, okay? So this is how you do that. For a permutation, you're going to type in n, how many options you have. Alright, so I'm just going to make up a question. Let's do like 6p2. Alright, we're going to do this one in the calculator. You're going to type in the number 6. Then you're going to go to mathprb, the same place where we found the factorial. And then you're going to go to NPR. I don't know. Is that the third one?
Yeah.
Is the third? It's the second option?
NPRs.
NPRs too. Okay, so type that in. Push that. And then after that, you're going to tell me what R is, which is 2. Press 2. Press enter.
30.
Okay, let's see if that worked. 6 factorial over 4 factorial. What did you say the answer was? 30? Alright, I want you guys to do it the other way and see if you get the same number. Try 6 factorial divided by 4 factorial.
Do the calculator first.
In a second. Do 6 factorial over, I want to show if you can get the same answer using the formula. Do you get 30? So that's why you get to use this is a little bit faster than having to do 6 factorial, divide, remember parentheses and all that stuff. You can just do it in your calculator. However, I do require you guys write down this and this. But you can actually do the calculator trick in your calculator to find the answer. Okay? For combination, I think it's just option 3.
Yeah.
Is that right?
30.
Yeah. So you type in n first, then go find the NPR or NCR, and then type in R, and then push enter. And it will give you the answer.
Oh.
This is just how you find factorial.
Okay.
Okay, so that's a little reminder on how to use the shortcuts in your calculator. But again, I require you guys to write the notation and what it would look like if you plugged it into the formula. But you can calculate just using your calculator. Alright, so the tricky part, again, one more time, the tricky part is knowing whether it's a combination or a permutation with the word problems. Make sure you're really, really careful with that particular idea. Alright? Does anybody have any questions?
Nope.